I wanted to talk briefly while we're here, looking at these bits of data, generally about the allocation of resources. Since it just occurs to me that I don't think we've actually talked about this yet. I was planning on talking about it while we talked about multi-indexes, but I think now is actually a really good time to kind of explain what's going on here and why we need to buy RAM, why we need to delegate bandwidth, all these other things. So when we talked about blockchains generally, the difference between Ethereum and EOS, one thing we talked about was Ethereum uses gas, and that stops people from running endless loops and taking up all the resources of the miners, the full nodes essentially. Well, EOS needs a way of doing that as well, and rather than putting the burden on dApp developers and users, the gas kind of thing, what they did is they came up with the CPU and net bandwidth. And what you do in order to enact transactions on the network is you have to have a certain amount of net and a certain amount of CPU in order to make those transactions happen, right? It's network traffic that you're given, just like you would be on the internet, and also CPU. Let's say if you were going to connect to a server, your server would have a certain amount of CPU, and therefore it can do a certain amount of computation given a certain amount of speed, things like that. Well, it's very much the same way here, but rather than paying in US dollars for like maybe a server or something like that, you're paying EOS in order to use the block producer's CPU and the block producer's bandwidth, net bandwidth. So what happens here is you stake your EOS to the system contract. The system contract keeps track of how much net and how much CPU you have, how much you've used, and how much you are supposed to get back. And so what happens is you stake your tokens, you do some things on the network, maybe you deploy a smart contract, maybe you interact with a smart contract. Well, these things take both net and CPU to do. While you're doing that, the amount that you are allowed to use, here you'll see there's the delegated, the used, the available, and the limit. Well, in this case, we've been delegated this much EOS. That means that we have a limit of this much KIB, or in the case of CPU, we have this much clock time, CPU clock time. We get 7.6 milliseconds. We haven't used any, right? Because I haven't done anything on the net since I've delegated this bandwidth to this Bob account. So therefore, I have the full amount available. But if I was to do some sort of transaction, like interact with somebody's smart contract or something, you would see that this CPU bandwidth would actually be drained. And maybe we'll do that in the next video in order to make this more concrete. But you'll see eventually over time that this used portion will eventually come back, and then your available limit or your available amount will start to go. Like, let's say I do a couple things, like maybe I'm trying to span the network, so I just send a bunch of transactions to the network. Well, you'll see this used number grow and the available number shrink. Well, then if I then stop maybe DDoSing the network, stop sending transactions, well, slowly this available balance will start growing, and eventually we'll get back to this equilibrium where 0 is in the used column and available is fully in. However, with memory, so that's how you are able to transact on the EOS.io network with net and CPU. However, with memory, that isn't the case. The reason you use memory is, if you remember, we went over the multi-indexes, and we actually did a couple videos where we were storing things in multi-indexes with the address book from OCI Computing. Well, that takes memory, and that to store things in a smart contract takes memory. In this case, it's RAM with all the other block producers. And so we need to be able to buy RAM in order to do that. But the problem with RAM is it doesn't get brought back to you. So let's say I use, 10 kilobytes of RAM in order to store a token balance on my account or something like that. Once that RAM is consumed and used to store in that smart contract, it doesn't come back. It doesn't grow back like the CPU and the net do. It's locked in that smart contract forever. I paid for it, but I also get to keep that RAM forever. Essentially, that token never goes away. That footprint of that token and RAM never ever goes away. But I can transfer that token and then release the RAM, and at that point I can sell the RAM back and get it at whatever the market price is. So currently the Bancor algorithm is what EOS is using in order to price RAM. And at this point, when I'm recording this video, the RAM prices have inflated absurd amounts based on speculation. People have been buying RAM and then not releasing it because they're not using it in any way, and that's driving the price of RAM up. So there are a lot of dApp developers that are really, really pissed off about this because they're wanting to do airdrops, or they're wanting to build things for users to use on the EOS blockchain, and it's costing them too much money. So those are the three kind of core resources that you need to be worried about while you are doing dApp development. Anyway, I wanted to go over that while we're talking about that here, because I think it's very, very important, and I think a lot of people misunderstand what's going on here. See you in the next video.